Hey everyone, I hope you are all doing well. It's been a while since I've done an in-person video like this, so I'm excited to talk about our subject today. So let's get right into it. Recently on this channel, I conducted a small poll on when my viewers think we will reach artificial general intelligence, or I'll just say AGI for short. And quite surprisingly, actually, my viewers thought, or at least the results were, that within 30 years, 72% of people thought that we would reach AGI, which a little bit crazy, but it's not quite impossible. So that's actually what I want to take some time today to talk about. What are some ways that this might possibly happen? So specifically, I want to talk about 3 ways that we could potentially end up reaching AGI. Now, before we talk about these 3 different methods, I first want to get out of the way 2 different issues. And the first issue is, let's be honest, AGI is a pretty poorly defined term. It means different things to different people. So the definition we're going to use for this video is essentially going to be an agent that can do anything your average human can do. Now, this is still a poorly defined term. Like what's an average human? I don't know. But you can get a rough idea of what I sort of mean by that, hopefully. That alone is a topic we could spend an entire video on, so please let me off the hook for this one. The second issue I want to get out of the way is that I'm sure lots of people will be asking or commented already, why would you know how we'll get to AGI? And your answer is, I really don't. There are a whole slew of different ways we may get there, and we may never get there. So I really don't know, but I can make a few informed guesses. And those informed guesses are based off my time working on ML. So working on ML as a hobby, also in industry at companies like Google, and finally at grad school where I've seen all the sorts of research going on in the industry and can get a feel for where the whole field is headed. These 3 different possibilities I've come up with are not all created equal. Some of them are less and more likely. Specifically for this video, I've ordered them from what I think is least likely to happen to what is most likely to happen. So if you do want to hear my personal opinion for what I think will likely happen, do stick around to the end of the video to see that. And the final thing I want to mention is, if you haven't already, consider liking the video, subscribing to the channel, and hitting the bell icon for notifications. I know I say it all the time, but because I'm such a small channel, every single one of you that subscribes really makes a huge difference. So with that out of the way, thank you so much. Let's get into method number 1. And this is what I refer to as the brute force method. This brute force method is probably the most similar method to how humans actually came to be. So to get started on this and explain what I'm talking about, let's start by talking about 4 different requirements for this method to work. The first thing you need is a model, so some sort of machine learning model or something that is sufficiently complex to, learn everything you would need to be a general agent. The second thing you need is a learning algorithm that's strong enough. Now, these first 2 are things you need actually for all 3 of the methods I'll be talking about, so I'll leave those out from now on. The third thing you need is a sufficiently complex environment, and this is by far the most important one. I'll explain why in a second. And the fourth and final thing you would need for this method is some reward function, any sort of reward function, so that you could perform reinforcement learning. And if you don't know what reinforcement learning is, by the way, check out my channel. I have plenty of videos on it. So the whole idea behind this is that if you have a sufficiently complex environment in a reinforcement learning problem, well, to achieve your reward or achieve your goal, you need to learn all the mechanics of how this environment works so you can best predict things and compete with the environment and possibly other agents. So this whole idea was proposed in a paper recently, actually, by DeepMind called, I believe it was Reward is Enough. And the idea they proposed was just this. If you have a complex enough environment, and the example they gave was a squirrel in the real world, right? So if you have a squirrel in the real world, it needs to perform all sorts of tasks. It needs to control its body, so that would be a control task. It needs to detect objects, and that, that's sort of computer vision sort of area. It needs to be able to do all these things. And then on top of that, it also needs other things like memory to remember where it's stored its nuts. They even mentioned that apparently squirrels fake where they bury their nuts so that other competitors can't figure out where their actual nut storage is. It's pretty crazy. And that could not have happened if the actual world itself was not complex enough to allow all those things to happen, right? And when we talk about the environment, in this case, we're also talking about other squirrels and other competition. So by having a sufficiently complex environment, any reward, at least they argue, should really be enough to elicit some complex behavior and end up at artificial general intelligence. Now, this is a very strong idea, right? The reward is enough hypothesis. And I think a lot of people agree with it. But even if you do agree with it, it begs the question, well, what is a sufficiently complex environment? Now, the obvious answer to that might be, well, real life, of course. Real life is sufficiently complex. I wouldn't argue with you there. So if we have real life as our environment, what are we supposed to deploy? What types of agents? We could think like robots, right? You know, we put robots in people's houses. We have maybe thousands of these. And then I guess the reward function could be something like human utility. So they would get reward based on how useful they're being to their human. And I don't know, maybe through some sort of distributed learning method, we could learn something. It gets a little fuzzy, but the issue here is that real life is just slow. It's very slow in terms of learning, especially when we are comparing it to the alternative of simulated environments. To give you an idea of how slow the real world is in terms of learning and sort of evolution, and to be clear, I'm not comparing this method directly to evolution. They're very different things, right? So I'm not saying these numbers are accurate at all, but it doesn't hurt to at least look at some numbers. And one number is from the first spark of life on Earth, the time it took to evolve to the first human on Earth was approximately 3.7 billion years. Now, again, we're not doing some sort of evolutionary search, so the situation is different and we're starting from a higher starting point. Even if we look, though, from the first human on Earth to the 21st century that we live in today, well, that was a span of 300,000 years to gather all the knowledge we have to this point. Again, the number is not directly relevant, but it does kind of go to show you how slow progression is in terms of learning in the real world. It would be so much nicer, right, if we could simulate something. So let's say that the real world is out of the question. Would other environments suffice? Are there any environments that are less complex than the real world that are still complex enough to yield AGI? And the answer to that is I don't really know. We could ask more questions on top of that, like to what degree would we need to simulate the environment? For example, would we need to simulate Newtonian physics or go down to the quantum level and simulate individual particles or even subatomic particles? And even if we could somehow figure all of that out, who's going to create all these assets that we need? Like, that is quite a major undertaking. It just doesn't really seem feasible to me. It is 100% possible that I'm going way too deep here, and even a fairly naive environment could be considered sufficiently complex, but we really don't know, and that's why this is the third and I think the least likely option as to how we could potentially reach AGI. With that out of the way now, let's dive into method 2, and this one's a bit more straightforward. It's the idea that you can create some sort of narrow AI that's goal is to create better AI. So that agent would then create a smarter agent, which would then create a smarter agent, which would then create a smarter agent, and so on. And you would have this iterative process of AI creating better AI. And this is, I guess, the whole idea behind the singularity, right? Is that once you have one agent that's smart enough, it can keep creating recursively better and better agents. Now, I used to have quite a few issues with this argument. Starting off with one issue is that is it really possible for such a narrow AI to create a better narrow AI and improve that recursively? I really wasn't sure, and to decide one way or the other seemed like quite a daunting task. And then let's assume, and this is the second problem, let's assume that this narrow AI could create better and better narrow AI after it in an iterative fashion. Would any of those down the line narrow AIs lead to AGI? Essentially, the question is, can a narrow AI create AGI? And again, this was a question that I certainly didn't have the answer to, and I was a bit skeptical. And it was OpenAI Codex recently developed, by OpenAI that actually started to change my opinion on this recently. So Codex is a model developed by OpenAI that can actually generate code. And this model is surprisingly capable. It's nowhere near what we need for AGI. I mean, I don't even know what level that is, but I'm pretty sure this isn't close. But it's a lot better than what we had before, surprisingly so. And even though it struggles in lots of aspects right now, I think there's some straightforward paths we can take to improve Codex. So some examples of those that I've actually covered in recent videos are, debugging its own code and iterative code generation along with extra testing. If Codex can learn to do those sorts of things, I could see this methodology really taking off. The idea of you create a narrow AI to eventually down the road create an AGI. Another reason I've grown sympathetic to this idea is, as I asked earlier, the question of can a narrow AI create an AGI is a really important one here, right? Because if you're creating a narrow AI that is going to create more narrow AIs and the goal is to create AGI, well, at some point, a narrow AI has to create an AGI. So can that happen? And well, I used to think the answer was no. I realized that the answer is actually a resounding yes, like this is very provably true. Unless you believe in intelligent design, or I forget exactly what it's called, but like, religious stuff, well, humans had to come from, even if it was a directed process, I think you would be hard pressed to say that evolution and natural selection are a general intelligence. You could even call those processes, in a sense, narrow intelligence, where their end goal is to create, I guess, species that survive longer and better. So recently I've honestly, opened up my heart a little bit to this method too, this iterative narrow AI approach, and I think there's actually a good amount of potential for this going into the future. I'm especially interested to see where Codex goes, to see if they go in the directions I was talking about. If you find this iterative narrow AI approach very interesting, there's actually a book I would recommend a lot. It's called Life 3.0 by Max Tegmark. And it's a really great book where it starts off with a great opening chapter where you have this narrow AI created by people that quickly evolves into an AGI. So if you're interested, do check it out. So finally, on to the third method, and this is the method that I find to be the most likely. And this is actually similar to method 1 in some sense, but I think a lot more realistic. So there are 2 requirements for this method to work out. The first one is that you need a fairly complex environment. However, fairly complex does not mean as complex as the real world. And while I've not given a strong definition to fairly complex, I could give you some examples of what I think are fairly complex. And the primary category of environments that I think falls into this category is any sort of virtual machine with access to the internet. And the internet is very key right here, right? So the internet gives you access to talking with people, watching movies, watching YouTube videos, reading Wikipedia articles. There are so many things you can do on the internet and so many things you can learn without ever being in the real world. And you can learn about the real world through the internet and through all the services offered online. Now, what is crazy is that there are already 2 environments I know of that actually fit into this category. So one of those is World of Bits, which is like an internet-based environment. I haven't experimented with it much myself, but I do know that it sort of allows you to explore the web to some extent. And the other one I know of is Android Env, which is a recent development by DeepMind, and it's essentially an Android simulator that you can use to run RL experiments on your computer. So using either of those 2 environments, you could imagine an agent could do all sorts of things by accessing the internet, and there are really very few limits to what you can do. Once you have a fairly complex environment like one of the ones I've listed, step number 2 is to have an algorithm for self-supervised reinforcement learning. Now, there are a lot of options out there today. One example that I think is very promising is automatic goal generation. So this is the idea where an agent automatically generates its own goals. So an example of a goal might be to watch this movie and describe something that happened in it, or to summarize some Wikipedia article, or play some game. There's all sorts of different goals that an agent that has access to the internet and some sort of computing hardware could have. But the idea is that all these goals would be self-generated. By self-generating all these goals, the agent could explore the state space and learn many things to do without ever receiving direct input from a human. Now, there is actually a name for this sort of area of research, and it's called auto-curriculum learning, where you automatically generate some sort of curriculum to learn by. It requires minimal human intervention, and it allows for agents to do all sorts of things in environments without ever needing direct human interaction, or at least having a very minimal level of human interaction. While it is possible, I think that could lead to AGI alone, I do think that it's unlikely. There's probably some sort of soft limit to what agents could learn on their own via some sort of intrinsic curiosity or automatic goal generation. So an optional step 3, if that doesn't get us all the way there, is to involve human input after the agent has already learned quite a bit. So one example of how you could do this is you could convert all these goals, or make sure that the goals are all represented in some human understandable form. So a quick example of that would be the English language. So instead of having a goal represented as a sequence of numbers, you could have it represented as a sentence, something like go play X game and reach Y points, right? So if we could do something like that, you can imagine a follow-up step where we go to like Amazon Mechanical Turk, and we have Mechanical Turkers generate just thousands of different goals you can do on a computer and feed these into our agent to help it learn different sorts of things. And so long as it can auto-evaluate, which is a big asterisk here, that's a very difficult thing to do. If you can auto-evaluate, you can do all sorts of things. So I guess that's the weakness in this method, is that I haven't really defined that very well. But if the agent can auto-evaluate how well it's doing on these tasks, well, you can imagine it could learn to do all sorts of things. And on top of that, this would also be an AI that could be directed by humans, even though we started with a self-supervised approach, by switching it sort of to supervised or just a standard reinforcement learning problem at the end, we could direct the agent to learn to do specific things. I think this method is the most likely because of the fact that we already have environments like Android M that are very complex and allow agents to interact with the internet. And we also already have really great self-supervised learning algorithms for things like auto curriculum learning and auto goal generation. Now, I will admit, I don't think those algorithms are nearly enough to where we will need for AGI, but it's really hard to tell because we have those two pieces to some extent, but we haven't tried scaling up this approach. Though we've seen big models like OpenAI Codex, we haven't really seen any huge reinforcement learning undertakings. Now, there are things like AlphaStar and AlphaGo, and there is OpenAI 5. So I don't mean that there's no big reinforcement learning projects, but none for general learning. They're all concerned with narrow AI. So I would absolutely love to see a company take up a huge RL project focused on general learning and some sort of unsupervised or self-supervised learning method, because the results of doing things like that for NLP have been tremendous. We get amazing models like GPT-3 and OpenAI Codex and BERT and all these other models. So it really makes me wonder what would happen if we went in the same direction with reinforcement learning. Now, those are not the only methods to AGI, but they are the three that I had thought of for this video. So if you have other ideas as to how we might reach AGI, definitely leave them in the comments below. I'll be looking through, and I'm very curious to hear what all of your ideas are. Anyway, that is all I have for now. So thank you so much for watching, and I hope to catch you next time.